Good evening, everybody. Welcome. My name is Terry Least. I'm the Vice President for Administration and Finance here at Montana State University. Certainly want to welcome you here tonight. Welcome to Montana State University. We are hosting this event in the aptly named Inspiration Hall because it is our hope that tonight's presentation by Dr. Rob Davies will help us understand the unique challenges that climate change will bring to our community and, more importantly, inspire us for solutions. Before we get started, I'd like to thank our sponsors tonight. First of all, the City of Bozeman, the Office of Sustainability here at MSU, the Norm Asbjornson College of Engineering, our MSU Honors College, the College of Letters and Science, the College of Education, Health, and Human Development, the School of Architecture, MSU Extension Community Development, and Institute on Ecosystems. Let's thank those folks for doing that tonight. So our students, faculty, and staff here at MSU are directly involved with sustainability, research, education, and more importantly, the application thereof on our campus and throughout the state and beyond. And where others see problems, we see opportunities. Opportunities to go beyond the minimum. Take this building as one of the most efficient, energy efficient buildings in the country, the one that we're sitting in tonight, Norm Asbjornson Hall. Opportunities to minimize our waste. A small research pilot to study food waste here at MSU is now a fully fledged partnership with the City of Bozeman. We diverted 540,000 pounds of food waste from the landfill last year to be used as useful compost. That's wonderful. We have opportunities to inspire. Our students are designing net zero buildings, energy wastewater treatment systems, solar-powered vehicles, improving the efficiency of renewable energy systems, and working to understand our natural systems and how to preserve them. At Montana State University, we are creating a sustainable future today. Again, I'd like to thank you for joining us tonight for this special event. We're going to welcome Dr. Rob Davies. I'll do the formal introduction in here in a minute. I just want you to know that after his presentation, we will have a Q&A session, and then there will be a panel discussion following that. Okay. Dr. Rob Davies is a physicist by training, focused on atmospheric physics, surface physics, and quantum optics. For more than a decade, he has engaged in critical science communication, principally focused on global environmental change and sustainable human systems. He has taught on the faculty of 3 universities, worked as a project scientist for Utah State University's Space Dynamics Laboratory, as a physicist and climate change communicator with the Utah Climate Center, and served as an officer and meteorologist in the United States Air Force. Dr. Davies' published scientific works are in the fields of spacecraft interactions with the space environment, the fundamental nature of light and information, and the Earth's climate system. In addition to teaching throughout the undergraduate physics curriculum, Rob has also developed courses in climate change, the science of Anthropocene, and the scientific storytelling. He also maintains an active public speaking schedule and has delivered hundreds of public lectures on these topics. Finally, Dr. Davies is the co-creator of the Crossroads Project, a performance science project bringing together music, imagery, and information. Please welcome, for the first time to the MSU campus, Dr. Rob Davies.
Thanks so much. Well, so thank you all very much for giving up a Tuesday night to come and listen to a physicist, as you heard. So my training is in physics. You heard my background. I had a friend once who told me, Rob, you're becoming so well-rounded as to be pointless. But it turns out to have been kind of the perfect training for what it is I do now, which is, as you heard, study global change and complex systems and human vibrancy. And in particular, I synthesize information from a huge spectrum of research about the interactions between our human systems of food and energy and economy with our Earth system, our life support system. soil, and water, and climate, and life. And try to understand what these interactions are telling us about us and our well-being and our vibrancy in the coming decades. And so what I'm going to do tonight is a refraction. So that information comes into me from hundreds and thousands of researchers, really, the work synthesized in my own brain and then sort of refracted out to you in the following synthesis of this story, which I'm hoping will be helpful for all of you. And the first piece of this is that when we talk about global change, the changes that are unfolding both on the Earth system and in human systems are so large and so rapid that the word change is really no longer appropriate. And so I choose this word disruption to talk about what is happening and the consequences of that disruption, how we respond. And so I've given the second title here of sort of defining radical in this age of humans. And we'll come back to that towards the end of the talk. And nominally, of course, I think what you all are expecting is the title of the series that I've been invited to talk to you on, which is Climate Change Now What? Right? And we're certainly going to talk about climate change, although I'm assuming most of you in the audience are clear on the basics of climate change. We certainly will review them, but I'm not going to spend a lot of time on it. But as you as a community, and I've known this is true, and I've got a lot more education on that today, that this is true, as you as a community, as a university, as Bozeman, as Montana, move forward now with significant steps in addressing this challenge of climate change, from the recommendations from the governor's panel that have just been released, as I understand, a couple of days ago, to the work of a number of very aggressive organizations working very hard to figure out how to move forward. As you get ready to really take those big steps forward, I'm hoping it will be useful to put this topic in some context. And so the first thing that I want to talk about is the scale of the challenges that we are facing as a result of our disruption of the planetary climate system, the scale of the response that these risks require of us, and then put this response into a broader context. And this is going to be important because as we all get ready in this country and in our own communities to take these big steps, we want to do our best to make sure they're in the right directions and the most effective. And so I'm hoping that this tale will aid you in placing your decisions and your priorities in this context. So we'll do that, and then what we're going to find is that the scale of the response that is required is really quite extraordinary. And I'm going to offer a brief apology right now, and I don't mean this gratuitously. The information that I'm going to synthesize for you and weave into this narrative is going to be rather jolting for many of you, I think. And I say that understanding that most of you in this audience probably understand that we have these issues and these problems to some degree. Nevertheless, I'm not trying to be gratuitous, but it's important that as we move forward, we do so understanding the full scope of what is happening, and therefore are able to better respond. So I want to conclude then with the mindset that I would submit as that will be helpful from which this required response of us that is really quite enormous can emerge. So that's where we're going. So that said, let's start with this notion of our disruption of the climate system. And it starts with the notion of emissions, a couple of terminology, and this is going to be important a little bit later on. So there's what we burn as an industrial society in the form of fossil fuels that produces carbon dioxide. And these are our emissions, what we throw up, what we dig up out of the ground and throw up into the atmosphere. We measure this in gigatons, billions of tons of carbon dioxide. We'll want that for a little bit later. Then, of course, these emissions accumulate in the atmosphere. We get concentrations of carbon dioxide molecules and other greenhouse gases, but carbon dioxide being by far the most important, in the atmosphere. And we measure those concentrations in parts per million. How many million carbon dioxide molecules in the atmosphere for every, how many carbon dioxide molecules for every million other molecules? Okay, so we'll need that terminology a little bit later on. Here's what those emissions look like over the last 1,000 years or so. So we're looking at parts per million on the left-hand side here. And what you see is that they're quite steady at around 280 or so parts per million for the last 1,000 years until we reach the Industrial Revolution. late 18th century, we start burning fossil fuels in larger quantities, and the concentrations go up until we hit the middle of the 20th century and we get this massive spike, which is ongoing. All of this increase is due to burning fossil fuels. We know this with very high confidence. It's something called an isotopic analysis of the carbon dioxide in the atmosphere that can tell us that this is true. And so there's where we were at 280 parts per million pre-industrially. Here's where we are today at 410. And actually, the daily, it fluctuates a little bit. Today it was about 416 parts per million. And this is what it's doing. It's warming the entire planet from the end of the 19th century to the middle of the 20th to today. And I'm going to show you this again. This is a map of temperature change, not temperature. So as the different places on the map go from the cooler blues to the warmer reds, they're warming up. But the North Pole didn't suddenly get warmer than the equator. But it is warming up faster. So let's look at that one more time. End of the 19th century to the middle of the 20th to today. It's a very rich data set coming to us, actually many, many data sets. But you can see immediately the entire planet is warming, and you can see that that warming is not uniform. The high northern latitudes are warming faster than the rest of the planet. Land surfaces warm faster than water, and we understand why this is. Here in Montana, in my state where I live now in Utah, we're warming at about twice the global average, decade on decade for the last 4 decades or so. But if you average it all over the planet, you find out that we've warmed a little over 1 degree Celsius global average over the last 100 years. Most of that has come in the last 40 years. And if you're metrically challenged, I understand, you can always convert a temperature change from Celsius to Fahrenheit by roughly doubling it. 1.8 is the actual conversion factor. So that's about a 2 degree Fahrenheit global average temperature rise. And that may not seem like a lot. It seems kind of trivial. When we walk out into the hallway, the temperature certainly changes more than that. But this turns out to be very large and very fast on a planetary scale, and I'll put it into context a little bit later. So the emissions of the greenhouse gases, particularly carbon dioxide, are warming us up. It is the structure of greenhouse gases, their molecular structure, that allow them to do this. They intercept energy that is leaving the Earth's system in the form of light, particularly infrared light. We can't see it, but it's there. And carbon dioxide interacts with certain wavelengths of this light in the infrared, converts that light energy that's leaving the Earth's system into thermal energy and holds it in the Earth's system. And that's how it works. And we understand the physics of this process, this greenhouse effect, really well. In fact, the physics equation that tells me that a molecule of carbon dioxide will absorb a certain color of light and turn it into thermal energy is the exact same physics equation that allows us to build pretty much all of this kind of thing. So we understand this really well. Now, this anthropogenic, human-caused global warming emerging from our emissions is disrupting the entire planetary climate system. We know this with very high confidence. And that's because everything is connected. And this is not too surprising. We, for example, know, most of us, that if you raise the temperature, you, roughly speaking, raise the air's ability to hold water. It can hold more water, roughly speaking. So evaporation intensifies when you raise the temperature. But then when you get more water in the air and you do get a storm, precipitation intensifies as well. And this is called an intensification of the hydrologic cycle, the water cycle. And if this were the only impact of warming the atmosphere, it would be huge. But it just scratches the surface because, again, everything is connected. And so when you change the temperature, everything else changes. So the cryosphere, the frozen bits on the planet, of course, are responding on a planetary scale. This is mountain glaciers, continental ice sheets like Antarctica and Greenland. This is frozen soil, tundra in the northern latitudes. This is mountain glaciers. This is the polar ice pack, which is frozen sea ice. This is even snowpacks, which is very important to us here in the Rocky Mountains. We change the way the atmosphere circulates. Weather patterns. And in the mid-latitudes like here, one of the most important features of this atmospheric circulation is the jet stream, for example. This is our major storm track. It determines where it rains and where it doesn't and how intense that is and how long it lasts. South of the jet stream is tropical warm air. North is polar cold air. When it starts to undulate, the jet stream, as it wraps around the northern hemisphere, it pulls tropical air further north. It drops polar air further south. And what we find is warming the planet this way is fundamentally changing the atmospheric circulation, in particular the jet stream. Weather patterns, storm intensities, storm locations, all of this changes. We're not done, of course. We change internal climate cycles, such as probably the best known, the El Nino-La Nina cycle, which is about how the oceans and atmosphere exchange energy. This is fundamentally changing. We change everything for the biosphere, where things can live and where they can't, where they migrate to, when they migrate, what biologists call phenology, when they go dormant, when they go to seed, et cetera, et cetera. And basically everything. Soil chemistry, atmospheric chemistry, ocean chemistry, lake and river chemistry, sea levels, everything changes. And this then is what we mean by climate change. So anthropogenic global warming is driving climate change. To summarize then, we're warming, the planet is warming, it's because of us, it's disrupting the entire planetary climate system, and the fourth thing that we're now going to spend some time on is this, and that it carries with it extreme risks for humans. And we know all of these 4 points with very high scientific confidence. And in science, when we say we know something, what we mean is consistent with many independent lines of evidence and inconsistent with no lines of evidence. So it doesn't mean that our knowledge doesn't refine and change. But it means that basically there's almost no chance it's going to overturn. Our fundamental understanding of this is not going to change. So we'll spend some time now on this last one, the extreme risks for humans. Again, this is scientific knowledge. And I want to mention also before we go forward, since the premise of this discussion is public policy. What are we going to do moving forward? Before we can actually have that conversation effectively and in good faith with each other, we need to be on the same basic page of the same basic page with the facts, right? I mean, most recently we've got a pretty big public health crisis unfolding in the coronavirus. All across the country there are public health departments, national and local, meeting to decide what to do. And around those tables, the people understand that this is a virus and they understand the vectors for transmission. And that is, the people showing up at the table are not saying, well, this coronavirus, it's not a thing, or it's not dangerous. That's what I mean by being on the same basic page with the facts. And so with climate change, these, from a public policy standpoint, these are the facts. Okay, so what is the scale that we're talking about, and both the scale of the risks and the scale of the response that is required? So let's start with risk. Here's a projection of North American temperatures rise, again, temperature change, over the course of the next 80 years or so. Again, the darker reds are more change. And this is under a high carbon scenario. So if we continue burning carbon in a similar pattern that we have been so far. So if we continue that, we can expect temperatures across most of North America to look something like this by the end of the century. That's a high carbon scenario. We can also do the calculation on a low carbon scenario. Under the high carbon scenario, that's roughly something on the order of a 13-degree Fahrenheit land temperature change across most of North America. The dark reds in the north there are about 25 degrees over the North Pole of change. On the left, low carbon scenario still carries with it quite significant change. This is sort of if we get religion right now and move aggressively towards decarbonizing our society, we can still expect across North America another 4 or so degrees Fahrenheit of average warming. And I like depicting it this way, with the low carbon and the high carbon, because it presents to us a choice. We can still choose either one of these futures. Now, the people who study these kinds of projections and try to understand what it means for us as people and as a civilization refer to the situation on the right as dangerous, carrying with it high impacts that require considerable adaptations. And they refer to the situation on your right, excuse me, yes. Situation on the left is dangerous. The situation on your right, the high carbon scenario, is catastrophic. And this term is used in scientific circles somewhat specifically, meaning unadaptable by human systems. Think food systems, transportation systems, health systems, water systems, etc. There's another important distinction between these two scenarios. Should we be following the low-carbon scenario on the left, we can expect to be leveling off at this place by the later part of this century. So this is sort of where it levels off and ends. We still have to deal with quite a lot. There are people in places around the globe who will deal with catastrophic impacts, even from the situation on the left. Hopefully not on a global scale. The situation on the right, however, is very different because should we be following this trajectory, we can expect that this is not where the change ends. It continues beyond the end of this century. This is just where we've ended the simulations. The people who study these refer to the situation on the right as moving to an entirely new planet. This is a dramatic change very quickly, not just for human systems, but for natural systems as well, which of course intensifies the effect on human systems. So that's our current path. The way that we're looking at risk is trying to project forward. What do we expect the future climate change to be? And then based on the impacts we've had so far, try to figure out what are the impacts of such a change. Let's look at snowpack here in the west. So this is spring snowpack when it's at its maximum. And we all know that we use snowpack here in Montana and certainly in my state of Utah as our water storage system. This is a giant reservoir. And most Utahns get most of their water from melting snow, for example. So let's look and see what happens to projections under a high carbon scenario for snowpack. So we're looking there in this part of the country, of course. The higher elevations, the deeper snowpack are the blues. The lower elevations, the thinner snowpack is the white. And I'm going to show you actual data from 1950 and then move forward into projections. And sometimes this does this. I just have to restart it. We'll try it one more time. So you can see that some years are snowier than others. This is actual data. But we always have significant snowpack. And of course, that's very important for us. Now we're moving into projections under a high carbon scenario. You see the snowpack thinning, even in the high elevations by the middle of the century. And as we move into the latter half of the century, the snowpack essentially disappears. It's not too hard to understand. As temperatures go up, when the precipitation comes, it comes more often as rain rather than snow. So this is a combination of precipitation and temperature projections, again on a high carbon scenario, which is the path we're currently following. Let's look at soil moisture, of course, incredibly important for agriculture. So these maps, this is a moderate emissions, somewhere between getting religion and continuing on as we are currently, the path we're currently on. As the different places on the map get browner, they get drier. As they get bluer, they get wetter. So continuing through the middle of the century, significant drying across the United States, continuing and moving further north into Canada through the second half of this century. Look at Alaska there becoming the new Amazon. Now these projections, of course, are a combination of temperature and precipitation again, and you can find yourself, as we do in my state and where I live in northern Utah, in a kind of a perverse situation where you might get even moderately more precipitation and end up drier. But that's again because of the increased temperature driving evaporation up. And it's a nonlinear relationship, meaning you increase the temperature a little bit, you elevate the evaporation a lot. So now let's look at a high emissions path. Again, significant drying through the middle of the century and then dramatically intensified through the end of the century. And again, if we're on this high emissions path, this is not where it ends. Continues on for decades to even a couple of centuries further. And again, it's looking at these two scenarios that we can think of as a choice that we are currently making. And again, the scientists, both social and physical scientists who look at these, the societal planners, projections, basically characterize again the scenario on your left as dangerous, requiring significant adaptation, and the scenario on the right, though, is catastrophic, again meaning unadaptable by human civilization. It's scenarios like this that we can see the obvious effects on, say, agricultural production. Invasive species, pests, certainly heat from the previous. But then there are the sort of the not obvious things that we don't always, those of us who aren't used to looking at these kinds of things, think about, that people like the defense planners look at. So it's projections like this that the US Department of Defense has issued over a dozen reports in the last 2 decades calling impacts to human civilization from climate change the single largest security threat the United States faces. This is the United States Department of Defense through the last 20 years. And they're not just looking at food systems, but they're looking at what does this do to social systems. And so look at the dramatic drawing. I'm picturing a wall going up between Canada and the United States. And of course, look at what's happening in Central America as well. Imagine the impact on populations as people move to try to find water and places where we can grow food. It's that very notion that makes this, I think, particularly effective in connecting our dots. Each dot on this map is a population center on a coastline of 1 million people or more. On our current trajectory, we can expect up to 2 meters of sea level change, and again, this is not where it stops, by the end of the century. 2 meters of sea level change currently displaces 200 million people from their homes. It annually floods another 600 million people through high tides and storm surges. So now you start to understand the position of the defense planners and the societal planners when you think about what's unfolded over the last decade across the Middle East and North Africa. As an intense drought across Syria in the 4 years preceding the civil war drove millions of people off the land into urban centers that were already stressed in a social structure as an additional stretch, which then collapsed into civil war, still not resolved, displacing internally 7 million people, a few million people externally, making their way across North Africa, joining with North African climate refugees who are leaving where they've been growing crops for hundreds of years and can no longer do so because the weather patterns are so disrupted. Trying to make their way across the Mediterranean into Europe, and we all, I think, are familiar with the political chaos that has been unleashed across Europe as a result of the migration, forced migration, understandable migration of a few million people. And now try to scarcities, etc. So this notion of catastrophic is not hyperbole. This is the best assessment of the people who really try to study what happens when this happens as it unfolds. So it's projections like the sea levels, like the soil moisture, the snowpack for us here and in other places, temperature projections like this, that lead to the statements from leading climate scientists such as Lonnie Thompson, quite a distinguished glaciologist at The Ohio University. Just let you read that for yourselves. This is an absolutely mainstream opinion, coming not just from climate scientists, but social scientists who study. I can find hundreds and hundreds and hundreds of such quotes in the popular literature, even such quotes in the scientific literature, which is almost unprecedented prior to this particular problem. This is Kevin Anderson, director of the Tyndall Climate Center in the United Kingdom and one of the world's preeminent modelers of carbon scenarios. So he looks at moving forward, how much carbon are we emitting, where can we get rid of it, where can we reduce it, how quickly, et cetera. Kevin says, a widespread view that a 4C future is incompatible with an organized global community. By 4C, he means 4 degrees Celsius of global average warming above pre-industrial, of which we've already had a little more than 1. But he doesn't stop there. This is this notion of catastrophic. And it's this last point that I want to spend just a little bit of time on. What does he mean by not being stable? So the climate system, like most complex physical systems we understand, is, in physics speak, nonlinear. Another term is complex, but a better term, I think more descriptive, is just twitchy. You can poke it a little and it changes a little. You can poke it a little and it changes a little, and you poke it a little too much and it changes a lot. Most complex systems behave this way. And we know that the climate system has behaved this way in the past from paleoclimate data. So you remember, for example, this graph of carbon dioxide emissions over the last 1,000 years. Actually, they were at about 280 for the last 12,000 years since we came out of the last ice age. And by studying paleoclimate data, scientists have discovered that the last time the Earth system was above 350 parts per million for for a significant amount of time geologically, call it a few centuries at least. This was an ice-free planet, and sea levels were close to 200 feet higher than they are today. And so this is identified as something called a probable tipping point in the climate system. You spend too much time above this, and it dramatically elevates the risks of moving to a very, very different climate system. In science, I think many of you have probably seen this analogy. We sometimes try to describe complex systems as this little model here of a marble and a dimple. And so if you disrupt that marble a little bit, the conditions around it tend to take it back to where it was. That's a stable system, or at least conditionally stable, because if you disturb it too much, you can cross thresholds, tipping points in the complex system that take it to a very different state. And as I said, we know that the climate system has behaved this way in the past. And think of it something like for those of you in the room, and I think it's most of you probably, who've seen the movie The Titanic, which is, the perfect metaphor for all things catastrophic. But there's this, so when you cross that threshold, it doesn't necessarily mean that everything just falls to pieces right away. But once you cross that threshold, the chances of going back become essentially impossible. Things are going to play out. Feedbacks that amplify the change that has been instituted take effect and move you further and further and faster to a new place. And of course, this happens on the Titanic. They hit the iceberg, right? But it's not so bad. It's kind of a glancing blow, and some champagne glasses tip over in first class, but everybody is like, that was not too bad. But the guy who built the boat is on the bridge, and he's looking at the lights. And he says, we have got to get everybody off the boat. And of course, the crew is perplexed. That wasn't so bad. He says, no, this ship can stay afloat with 4 compartments flooded, not 5. And he can see the lights, and they're flooding 5 compartments. And he knows that ship's going to end up on the bottom of the Atlantic. And it didn't happen right away. It took a few hours to play out, but that's where it was headed. So this is the notion of tipping points in complex systems. And of course, when the consequences of crossing those tipping points are very high, you really don't want to get anywhere close, because it's not clear to climate science where those tipping points are as we move forward for the climate system. So as I said, we know that the climate system behaves this way in the past. The glacial, interglacial cycles of the last several million years are an example of that. So the blue is the glacial cycle, where we've tended to like to be. And then we pop up every 100,000 years or so into these interglacials, which is where we are now. So that's in the back there. And there are tipping points that come into play as we change from warm to cold and cold to warm. And we understand those tipping points pretty well. The question, of course, is that are there tipping points as we warm further? And as I said, there's strong circumstantial evidence to suggest, yes, there are. In fact, there are at least 9 tipping points that climate scientists worry about quite heavily. And so we've wandered off into this sort of no man's land, moving from the Holocene to what geologists have now called our current geologic epoch the Anthropocene, the age of humans. We're now the single largest driver of change on the surface of the planet. And the question is, how close are we to tipping points? And the answer is, we're not sure, but it seems like we're quite possibly very close. And not just 1 or 2 tipping points, but a whole cascade of them. So from a risk management standpoint, of course, you don't want to get anywhere close to that. When the consequences are very high, where's the cliff? And the uncertainty is there. Uncertainty is not your friend. You want to stop well before you get there. And so this is what we don't want to happen. Hopefully also this diagram makes it clear that when we look at the news and we see the dramatically intensified tropical storms, heat waves, fire seasons, et cetera, and it's often referred to in the media as the new normal, hopefully this diagram makes it clear that we are nowhere close to the new normal. From a risk standpoint, we're just getting started on our current trajectory. And so that's what leads to these kinds of statements. All I can say is this is an absolutely mainstream opinion for the people who study, and the many thousands of people who study the situation that we're in. So that brings up, of course, the next situation. So that's the scale of the risk. Couldn't be larger. What's the scale of the response that's required to mitigate this risk meaningfully? Not solve climate change. This is not a problem that can be solved. There are already people on the planet, in places on the planet, who have experienced catastrophic impacts. That can't be reversed. There are already species that have gone extinct. That cannot be reversed. There are landscapes that have been devastated, whole communities. What we can do is mitigate the scale of the damage to come. Those two choices that you saw, left and right. And the physics equation in its most basic form is really simple. More carbon is more risk. And again, it's very important that we think of this as a risk management exercise. So that allows you to, if you can identify something that you think of as a danger line, and in the climate world that's been, well, where do we move from having sort of regionally big impacts, even catastrophic impacts, to globally big impacts, lots of regions all at the same time. And for the last 30 years or so, it's been felt that that line was about 2 degrees Celsius of global average warming, again, of which we've now warmed a little more than 1. So if you can identify that line, you can calculate a carbon budget. In other words, how much more carbon do you think you can throw up in the atmosphere and still stay below that danger line? So for the 2-degree danger line, in 2012, 8 years ago, a very large international modeling study was put together to try to figure this out. And the conclusion of that study was we had about 1,000 gigaton budget remaining, 1,000 billion tons of carbon dioxide to stay below that danger line. And the parameters of the study were you run the models, several dozen models, several thousand times, and you do statistics on the result. And you say, well, how often did we go above that 2 degrees and how often didn't we? And the parameters were, the budget was calculated for an emissions where we stayed below that danger line 2/3 of the time. So this is a 2/3 chance of staying below that line. This is not really aggressive risk management. That's 2 bullets in a 6-shooter playing Russian roulette, and not one of us in this room would pull that trigger. Nevertheless, this is not a particularly aggressive risk management budget, but there it is. Now, that was 8 years ago, and we've burned through some of that budget in the 6 years to 2018. In 2018, however, it was discovered that the Earth is actually sequestering more energy in the system, trapping more energy than we thought it was. It was being hidden in the deeper oceans where it wasn't originally thought that it would go this quickly, but it has. So we've been absorbing more energy, which will eventually make its way back to the surface waters in the atmosphere. So the budget needed to be reduced by about 25% based on that. It's also understood over the last decade or so, certainly in the last 5 years, that the impacts from the warming that we've experienced so far and the climate change that we've experienced so far have been on the high side of what was projected to both natural and human systems. So bigger impacts for the amount of change that we've seen. That led to a revision of what's the danger line from 2 degrees down to 1.5 degrees with a concomitant change in the budget. So that's where we were 2 years ago, and we burned through about 40 gigatons every year. So that's where we are today. This is our budget, to the very best that our best science can estimate. Is there uncertainty in that number? Absolutely. But once again, when the risks are this high, that uncertainty is not our friend. So we won't even really want to burn through this budget. How fast are we going to burn through this budget? Very easy to calculate on our current pattern of consumption and emission. About a decade. This is that budget relative to the traditional reserves of coal and oil and natural gas that are currently underground. We've found them and we're exploiting them. We're digging them up. So the physics tells us that any meaningful notion of risk management says that we can only burn something on the order of 10% of the reserves, the traditional reserves we're already exploiting. This is not politics. This is not liberal or conservative or right or left. This is just physics. And if you include the reserves that we're exploiting in non-traditional fashion, such as tar sands and fracking, which we should include because we are exploiting those reserves as well, the reserves are, of course, much bigger, and the physics says that you can really only burn 5% of that. So this should be quite clarifying for a number of parties. If you're a fossil fuel company, no need for further exploration. We can only burn 5% of what we've already found. from any meaningful notion of risk management. If you're a society interested in mitigating this risk, certainly no need to subsidize the exploration for new fossil reserves, which we heavily do. We can't even burn most of what we've already found. Now, if we're to meet that budget, what does that look like? We're back to emissions now. Remember gigatons. Here's our global emissions pathway for the last 30 years or so, since 1990. 20 gigatons in 1990 being emitted, about 40 gigatons last year, and we continue up and up and up. Not surprisingly, what needs to happen is this. We need to peak, and then we need to decline, and we need to decline to zero. As long as the emissions are not zero, the concentrations in the atmosphere continue to rise. When the emissions go down, the concentrations still continue to rise. They rise until we get to zero. We've got to do this as quickly as possible. Now, this is big and hard, and a lot of people call it radical. And in the precise sense of radical as big and extreme, yes, that's absolutely true. But we often use that word radical pejoratively, irrationally extreme, right? He's a radical. I call this a rational decarbonization. It is what is required of us to mitigate this enormous risk. For the next 10 years, that's where we're at here, from 2020 to 2030, this is what our emissions are expected to look like on our current path, continuing to go up. Should all of the nations in the world who've signed on to the Paris Climate Accords, which is all of the nations in the world except the United States, meet their obligations, this is what those emissions will look like in the next 10 years. And this is what is required to meet the budget that I just showed you. The next 10 years is by far the most critical that any of us will ever live through. The next 10 years is by far the most critical. So you can see that the Paris Accord in and of itself certainly is nowhere close to what we need. It was never intended to be. It was always intended as a first step to turn the ship and get the inertia built. But nevertheless, clearly it's not enough. There's the budget. If for the math nerds in the class, if you integrate under that curve, it gives you the number I gave you before. Now, if we peak this year, which is how I've got it drawn, and go down, that's one thing. If we wait another year and peak a little bit later, well, we burn more carbon up front, so we got to make it up on the back end. In other words, every year we delay in peaking, it gets harder. And if we had started in 1990 when we absolutely knew we needed to do this, and we were poised to do it, remember George H.W. Bush on the lawn of the White House saying, this greenhouse effect is nothing, it hasn't met the White House effect yet. We're going to fix it. If we had started along that path in 1990, it would have been almost trivial to meet this, to do this. But we've waited so long through a process of intentional predatory delay by lots of bad actors in our society, and that's a different discussion. But regardless of how we got here, this is where we are. Every additional year makes it dramatically harder. So what does this look like if we were to actually do it, though? Roughly speaking, we need to cut our emissions in half every decade for the next several decades. We need to cut our emissions in half every decade for the next several decades. What that means globally is a 7% annual reduction. We've never come anywhere close to this. We've only gone up. 7% every year, we got to be less to meet this pathway and stay within that budget. If we don't, the risks to catastrophic impacts rise dramatically and quickly. Now, there's a catch. Not all of us are equally responsible for the predicament we're in. About 10% of the world's population is currently responsible for 50% of our energy and material throughput. For the purposes of this discussion, 10% of the people in the world are responsible for 50% of our emissions. If the top 10% of the world's emitters, those with the largest carbon footprints, were to reduce their emissions not to austerity levels, but just to the average European citizen, whose social outcomes, by the way, are better than the social outcomes in the United States on just about every metric. the top 10% were to reduce their emissions just to the average level of the average European, that would cut our emissions today by a third. There's a lot of room at the top to get rid of those emissions. The world's top 20% emitters burn through the world 80% of the world's material and energy throughput. Let's consider the top carbon emitters 1% in the United States, top 3.5 million people, and compare that to the bottom 1% of the world, about 75 million people. These 3.5 million people emit 2,500 times as much as those 75 million people. In other words, it would take 188 billion of the world's lowest emitters to equal the world's highest emitters. So we can see where the fat is, where it can be cut out, and where it isn't. So if we apply that to this process then, it's probably not fair to ask Sri Lankans and Moroccans and Bangladeshis and Kenyans and Nigerians and Sudanese to cut their emissions 7% every year. They're just trying to turn the lights on. And so if we say that, well, at least certainly in this next decade, in order to give them a little bit of elbow room to continue to develop on a very fundamental level, the world's developed nations who are most responsible for the problem we have and who are most capable of figuring this out, we have tremendous wealth, we have tremendous capability because of this. If we put that burden where it belongs, I think, on any notion of social justice, then really the developed nations need to cut their emissions something on the order of 15% annually. This is just enormous. It's not at all clear that we can do this. Technologically, we can. We have every bit of technology and knowledge on a technical sense and a scientific sense we need to do this. I'm not saying there aren't some challenges to be overcome, but they're not that significant, not for a nation that's committed to it. This is now almost entirely a cultural problem. We have what we need technologically, to the extent that this is a technological problem. It is now mostly a cultural problem. So this is the story with climate change. We need to bend the emissions curve now. We need to reduce our emissions in the developed world, everyone of us in this room, by 15% every year. That cuts the global emissions in half every decade. And this is applicable on any scale. And this is kind of an important part of this conversation. So this means that this is applicable at the household scale, at the university scale, at the community scale, at the state scale, at the national scale. 15% a year. Now, if you're, I think, as most of us are, you don't want to go to where we've been looking at, and you say, well, what can I be doing? You're looking at your personal life, and you say, well, what can I do? I'll tell you this. Cut your personal emissions 15% this year. Can you, and how do you do that? Can you drive 15% fewer miles? Can you fly 15% fewer miles? Can you eat 15% fewer animal products? Industrial animal agriculture is a huge piece of this puzzle. It's, for all of us in this room, it's among the top 3 of our personal footprint. That's why it's there. Now, that's pretty easy. I think most of us could do all of that without blinking. But then we got to do it again next year. And it gets a little harder. And then we got to do it again the year after that, and it gets a little harder. And the year after that, and it gets a little harder. And the reason it keeps getting harder is because the systems that we're embedded in fight us. If you take that budget that I showed you earlier, 340 gigatons, divided among the world's 7.5 billion people, everybody gets a share. Here's your lifetime carbon budget. It's 44 tons per person. In Utah and in Montana, we, as an individual, are going to burn through that budget in about 2.5 years. We consume something in the order of 19 tons per year. That's our carbon footprint, just living here. Now, let's say you go home and you turn off all the lights, you refuse to get in another fossil fuel-powered car, you turn off all the heat, you never fly, you go down to the basement and you just decompose on some garden seeds. You live the life of a total ascetic. Your footprint, and I haven't looked at this for Montana, so I'll give you Utah. In Utah, my carbon footprint would go from 18 or 19 tons per year to 6 tons per year. Just existing in that society, the infrastructure of that society, is 6 tons per year per person. So in other words, if I lived an impossible life of an ascetic, just trying to contain this problem with my own personal behavior, I will burn through my own personal carbon budget, not in 2.5 years, but in about 6 or 7 years. It doesn't buy us very much. It buys us something for the first few years, and we're in such a state now that we need that. I'm telling you to go home and cut your emissions by 15% this year, if you can. More if you can. But I'm telling you that doesn't take us where we need to go. It's systemic change that has to happen. So if you're thinking what to do, I'm asking us all to plug ourselves into efforts that are ongoing to change the systems that create this problem. That's fundamentally transforming our energy system, our food system, and our economic system. They will transform, but hard landing or soft, right? Do we just let them crash, or do we take control? So that's the task. Now, in any rational public presentation, this is where we would end. But this is a radical public presentation. That's climate change. But climate change exists in a context. Climate change is not a problem. Climate change is a symptom. There are other symptoms. Do not try to look too hard at these graphs. All I want you to take in from all of these different graphs is the shape. Low to high, low to high, low to high, low to high. These are what's happening to the whole Earth system. Think of it as our life support system. So in the atmosphere, fundamental chemistry, these are greenhouse gases. Not surprising. Carbon dioxide showing you what I already showed you. Same with nitrous oxide and methane, also very powerful greenhouse gases. And notice when the spike really starts to happen, the middle of the 20th century. Impacts on stratospheric, depletion of stratospheric ozone, which thankfully we got a handle on. Surface temperature, basic ocean chemistry, acidification, having huge impacts on marine biology. Marine fish aquaculture, massive extraction on human, so depletion. Same with coastal aquaculture, nitrogen to coastal zones, that comes from industrial agriculture and causes huge dead zones in the oceans and coastal waters. This so-called eutrophication, we've all, I think, heard of. Impacts to land systems as well. And again, look at where the massive impact starts, is kind of basically starts to scream up in the middle of the 20th century. This is documented by thousands and thousands of studies and put in synthesis reports like the Intergovernmental Panel on Climate Change and the Intergovernmental Panel on Biodiversity and Ecosystem Services, the National Climate Assessment, the WWF Living Planet reports, the Global Footprint Network, synthesize huge volumes of science. We know what I just showed you with high confidence. Let's take a look at what that means in the biosphere. This is not climate change. This is forget climate change. Ecologists tell us that in the last 40 years, we've wiped out about 60% of the world's living creatures. This is hyper-extraction, hyper-consumption, hyper-pollution, hyper-habitat destruction. The ecologists also tell us that the extinction rate is now something between 100 and 1,000 times elevated beyond the background extinction rate. We're losing species at something on the order of 20 to perhaps 60 a day. It's from habitat destruction. Seabird populations down 70% since the middle of the 20th century. Elephants down 70%. African lions, 90%. Large fish, 90%. Sharks, 95%. It goes on and on and on and on in just the last several decades. This is not climate change. The ecologists tell us the impact to species and to populations is only 10 to 15% from climate change. The rest is from massive habitat destruction, massive extraction, massive pollution. Over a 3-year period, a few years ago, we lost 20% of the world's corals in a strong ocean warming event. The marine biologists tell us that if we go to 2 degrees Celsius instead of 1.5 degrees Celsius, we can expect to lose essentially all of the world's coral reefs. These are the tropical forests of the oceans, home to a quarter or more of the species in the oceans. Hugely important to the ocean ecosystem. The oceans without the coral reefs are fundamentally transformed. We're on track to happen sometime in the 2040s, by the way. In the last 30 years, across Europe, 3/4 of the flying insects have disappeared. Over 90% in the last 4 decades in Puerto Rico and across the Caribbean, as an example. Similar numbers for the birds that feed on these insects, not surprisingly. The trends in the Earth system are extraordinary and utterly unsustainable for humans. And again, this is not climate change. So why is this happening? Here are our socioeconomic trends. Let's think of them as the people trends. Again, notice the shape. The middle of the 20th century. Real GDP, think of that as a proxy for material and energy throughput, consumption. Very tightly tied. Foreign direct investment, think of that as a proxy for globalization, moving from regional to global impacts. And again, look at the shapes of the curves. Again, international tourism as a proxy for globalization. Now, this is what the people who study this call the Great Acceleration, and it's a key point. Because in the discussion with policymakers and with our fellow citizens about we've got to do something about this, it often goes something like this: blah, 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 environmentalists, blah, 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 doomsday, Chicken Little. They always say the world is coming to an end, blah, 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 blah. You know, never happens. Something has fundamentally changed in the last half century. And the terminology, the bumper sticker version of it, is that we've gone from a small world on a big planet to a big world on a small planet. Small world on a big planet means the human metabolism of extraction and consumption and excretion of our wastes was small compared to the Earth system. And so while you could have locally or regionally sort of catastrophic environmental impacts, it wasn't affecting the entire Earth system. But we've gone, since the middle of the 20th century, from a small world on a big planet to a big world on a small planet, meaning the human impact, the human metabolism is now on scale with the Earth systems themselves, and it's fundamentally disrupting them. These are symptoms. These are the causes. So it leads to statements like this. From a recent article in one of the premier scientific journals, this one, Nature. We know this. This is not climate change. Climate change is a piece of that. Fix climate change tomorrow. The stuff I just showed you does not change. And has led, as I mentioned before, the world's geologists to rechristen our current geologic epoch, the Anthropocene. Human impacts on the planet are now the single, humans are now the single largest driver of change on the planet, outpacing all natural changes. So let's look at the pathology that's causing this. And it's got one word. Uh-oh. You know, this projector is washing out those grays. So there's the word growth there. I don't really need it, but just imagine the big word growth. Now picture that. I've colored in a few pixels there. If I were to continue to color in the same number of pixels every second, that same little square every second, it would take me 10.5 hours to fill up that screen. I did the math. However, that's called arithmetic growth. If I were to exponentially grow that number of pixels, which means grow it by a certain fraction every time period, I'm going to double it every second, I'm I'm going to double the number of pixels every second. So I'm going to throw it up there in the corner. Let's see how long it takes. You ready? Go. 2, 3, 4, 5. "15 seconds. That's the power of exponential growth. Here, the doubling time was 1 second. If I grew those pixels at 3.5% every second, or rather every year instead, the doubling time would have been 20 years. And it would have taken about 300 years to fill up that half of the screen. And how long to fill up the other half? 20 more years. One more doubling time. 3.5%, 3 to 3.5% is what the global economic powers tell us on purpose we need to be growing our economy, which is a strong proxy for material and energy throughput. Imagine that whole screen were our planet's worth of resources. This is the insidious nature of exponential growth, right? When you're on the hairy edge, it just doesn't feel like it. We're on the hairy edge after 300 years and it hasn't been that long, but we've used up half. And you look out over the vista and you say, oh my God, we've been this massive expansion for 300 years and we've still got half left. And then 20 more years and it's gone. Now the economists they don't even make bones about it, incredibly dismissive of this complaint of physicists, that you cannot grow indefinitely on a finite planet. And they use one word to tell me why I'm completely wrong. Anybody know what the word is? No, not capitalism. That's the vehicle for it, one of the vehicles. What? Innovation. We will innovate our way out of this. The Stone Age did not end, my friends, because we ran out of stones. We figured out something else to use. And again, that was kind of an okay strategy for the last century or so when we were a small world on a big planet. But now we're a big world on a small planet, and we're bumping up against physical limits. And this is completely unphysical, but let's assume we could innovate our way tomorrow to 3 more planets worth of resources. There's no reason to think that we can do this. But let's say we did. There they are. We burned through one at 3.5% growth. How long to burn through the next one? Doubling time? 20 years. Now we've got 2 left. At 3.5% growth, how long to burn through the next 2? 20 more years. We do something absolutely fantastical, and it buys us a few decades. We're bumping up against physical limits. And so when you hear the notion everything has to change, everything has to transform, this is where it's coming from. Everything has to transform. And it will. We will not have this system by the end of this century, probably not even by the middle of this century. We will not have it. In 2016, we were burning through about 1.6 planets worth of resources, meaning we needed 1.6 planets worth of resources to sustain our extraction, consumption, and excretion at its current levels. Now, you can do that for a while if you got a bank account, right? You can spend more than you earn, but you got to draw down the bank account. Eventually, you get to 0. Now, that got recalculated a couple of years ago. It's 1.7 planets. So we are over-consuming our resource base currently at 170%. Our plan on purpose as a society, as driven by the economists, is to grow at 3 to 3.5%, which in physics terms mean our plan is to be over-consuming by 3 planets worth in 2 decades and 6 planets worth in 4 decades. And of course, the relevant feature of these numbers is they're bigger than 1. Now, the science of complex systems is pretty clear that the chances that we hit anywhere close to that level of overshoot before major wheels start falling off the cart are essentially 0. In other words, we're not going to get to 6 planets worth, or at least from a risk management standpoint, there's every reason to believe you should not plan on ever getting there. we should probably not plan on getting here. So again, forget climate change. This is not climate change. This is hyperconsumption on a finite world. It's the underlying pathology that is driving climate change and driving our massive impact on the living world as well. If everyone on the planet consumed today at the rate we in this room consume, it would take between 4 and 5 planets today to sustain us. Remember, some people need more planets than others. Who among us has the elbow room? Which societies are the ones most capable to dial it back and with the most responsibility to do that? Okay, so I told you about climate change, and that was pretty bad. In fact, it's awful. And we should have stopped there, but instead, I took you here. Why did I do that? As we move forward, climate change is by far the most acute problem we face. We crash food systems, we crash economic systems. It comes with enormous human suffering, but you can sort of imagine recovering from that on decadal scales. If we move past tipping points in the climate system, there's every reason to believe there's no going back. So as we move forward with the giant steps that are needed for climate change, we need to understand the context in which they're being plugged, because there are steps we can take for climate change that synergistically help all these other problems, and there are steps that we could take for climate change that exacerbate these other problems. So as you move forward as a community, and as we move forward as a nation, and even in your own mind, try to get a sense of the totality of this. And it also has one other feature, which is great. Whatever your interests, whatever your talents, whatever your means, there is work for you in this. If you want to, sure, if you want to be an environmental scientist and a physicist, plenty to do. But if you want to be a chef, if you want to be a farmer, if you want to be an architect, a lawyer, a financier, a banker, an artist, artists are who affect most effectively cultural transformation. There is work for you in this. Just know where it fits. Now, so this brings us to the last bit. I promise we're almost done. And I think this quote from Eisenhower just perfectly fits where we're at. What he means by this is if you're not finding a way out of your problem, let's call it climate change, it's probably because you're not considering enough pieces of the puzzle. And once we consider all these other pieces, then doors begin to open and pathways begin to form. And here's what I mean by that. We need a mindset. And I can't make any claims to being an expert on this. I can tell you that for the last 15 years I've been studying these problems and lots of examples of social transformation and trying to understand what are effective steps and what are not effective steps and all of that. But I can't claim anything more than really dilettante status. But I can tell you what I find most compelling as a mindset. And that is this. We have got to adopt the appropriate mindset, which is that of we are in a civilizational emergency right now. The problem, of course, is it doesn't feel like it to most of us in this room. I'm telling you we're on the hairy edge, but you're going to walk out into your lives and they're pretty nice. Nice cars, nice homes, nice food, nice education. I'm not saying we don't have problems, and some of us might even have quite acute problems right now. So I'm not trying to demean that or belittle that, but I'm just saying that it just doesn't feel like it. But we are, in fact, in an emergency, and again, in a very technical sense. An emergency is a situation that requires immediate action to prevent catastrophic outcomes. And that's what we need, because the tipping points, the risk of these tipping points is just far too high. We need immediate action to prevent catastrophic outcomes. And once you adopt the mindset of a planetary emergency, other things happen to the way we think about it. Let me end with the following. First is this notion of radical versus rational. Now again, I'm talking about radical in the pejorative that we often say it in society. We think of it as. So let's define this notion of radical. Let's start with what's not radical. It is not radical for someone to know about a crisis and respond. It is not radical for people or for institutions to know and respond. What is radical? in the pejorative sense. Irrational. Knowing and not responding. So I would argue, and I'm not alone in this, that the radicals in the conversation are those who get that we have these problems but are still not behaving like it. So all of those hardcore skeptics that just will not pull their heads out of the sand, that will not listen to the information, I'm not calling them the radicals. They're just rocks. You don't do anything with them but step around. So unfortunately, I apologize, but you all fit into this category right now. Now you know. And the question is, will we behave accordingly? This is radical. This is radical. This is radical. Intense, extreme industrial pollution of our life support system. This is radical. This is radical. Oh. Not radical. Now, I'm not saying they do what's necessary, but at least they called it what it is, a crisis. In October, 7 million people joined the youth strike around the globe, walking off their jobs, walking out of school, demanding action from their governments on climate change. Not radical. Say what you will about this, but this is rationality defined. The second thing that happens when we think about an emergency is this notion of viable versus necessary changes dramatically. In an emergency, viable is not a question. You identify what is necessary and do everything you can to do that. And making it viable is just another step along the way. We set new goals. How many of you in this room think it would be viable for us to ban the production and sale of all new automobiles? I see one hand. Doesn't seem like a viable thing to do. I'm not even necessarily saying it's necessary, but just as an example. We did it. In December of 1941, Congress passed a law outlawing the manufacture and sale of new automobiles. The president signed it. They said, Ford, GM, you're making tanks, you're making airplanes, you're making trucks, jeeps, munitions, artillery, everything we need to meet the emergency of this crisis, of World War II. What would have been unthinkable a month before was done. When you're in an emergency, the notion of viable completely changes. Now, with climate change, technologically viable to fix this, I told you, we can do that. There's lots of road mapping and planning and calculation to tell us that that is true. I'm not saying it's trivial, but it's doable. It's the politically viable, the socially viable, the culturally viable. Ground all the flights that are in the air right now. Tell the people to get off and find their own way home, and you can never fly again. We did it. September 11th, 2001. On September 10th, 2001, how many of you in this audience who fly would have thought the TSA was even remotely politically viable? No one. When you go to a mindset of emergency, that changes. And what is making something viable, socially, politically, is just another step along the way to doing what is necessary. Can we do 100% renewable energy? Yes. Plant-based diets seems completely ridiculous. Industrial animal agriculture is a huge fraction of our emissions. I'm not making judgments on the way people eat or animal welfare or any of that. I'm just saying this is a fact. High-speed rail in Utah, 3/4 of our population lives in a 100-mile stretch, and we have no train. Putting a price on carbon, that's putting a backpack on to go up Mount Everest. Absolutely got to do it, but it's not going to take us where we need to go. We've got to keep the fossils in the ground. If they get extracted, they'll get burned. And at this point, it's all about counting molecules. This next 10 years is most important. Our goal is a sustainable and a just and a vibrant existence for humanity. And we will be sustainable pretty soon. But there are many, many sustainable states for humanity that are not very pleasant. By definition, we will get to a sustainable state. We want the nice ones, the just and the vibrant ones, and for that, we've got a plan. We can't just stumble into the desert. That takes us to a pretty bad place. Finally, I want to address this notion of hope and despair. You're sitting there thinking, he's giving me no hope. I'm not here to give you hope. I have no hope to offer you. I really don't. I'm not kidding. I also have no despair to offer you. It's the complete wrong framing for an emergency. You don't hope you get out of a burning house. You just get out. Or you die trying. You identify a next step and you take it. I think most of you know who this is, complex character, but in World War II, another great catastrophic metaphor. In 1940, he takes over in the spring. The Chamberlain government's talking about surrender, who just quit and handed the reins to Churchill, who 4 years before told him, you cannot appease, right? We are entering a period of consequences. This is the famous speech from 1936 from Churchill to Chamberlain. 4 years later, the consequences have piled up. Chamberlain says, I quit. Churchill takes over. The British Expeditionary Forces in Europe, 350-some thousand British troops and all their equipment are about to get wiped out on the beaches of Dunkirk. They're trapped. The Chamberlain government's been talking about surrender to Hitler. Britain is within days or weeks of invasion. It is completely hopeless in this framing of hope and despair. And this is when Churchill gets on it's the speech, right? It's we shall fight them on the beaches, and we shall fight them in the hills, and on the landing grounds, and in the cities, and we shall never surrender, and we shall never surrender, and we shall never surrender. It's extraordinary, the conditions under which he gave this speech. It is, in fact, hopeless. But that speech does not sound like hope, and it doesn't sound like despair. It is absolute, utter resolve. It is just resolve. And what's the next step? The next step was to save the troops on Dunkirk, which they did. Watch the movie. What's the next step? Get the United States behind us, which they did. Watch the movie. What's the next step? What's the next step? What's the next step? That's where we are right now. Don't worry about hope or despair. In the days when you can't get around it, just take a day off. Go into the mountains. Let the sap rise, rejuvenate yourself. But come back and forget about the hope and forget about the despair. This is what I do anyway. And go to the resolve. It's about courage. I'm going to give you one more example from popular American culture. Apollo 13. And just for those of you who don't quite know the situation, the Apollo launches, it's on its way to the moon. There's a command module, there's a lunar module which will land the astronauts on the moon. There's a command module which they will come back from the moon and switch to and take them back to Earth. They're going to the moon together in these two modules. That's going to come up in the clip. There's been an explosion on the way to the moon. All hell is breaking loose. Nobody's quite sure what's happening. The engineers back in mission control are trying to figure it out, and you'll see the demographics of aerospace engineers in 1970. This is who's trying to figure it out in this particular case. Here's what. Oh, do I have sound? We tested it. Are you working on it up there? Let's give them a second. We may not be able to get it. All right. They don't know what to do. And this guy says, they're not going to last 44 hours. They're pulling 16 amps. We've got to shut everything down. This guy says, you can't run a vacuum cleaner on 12 amps, John. He says, I don't care. You got to shut everything down. I've been looking at the data for an hour, and that's the deal. And Ed Harris says, that's the deal. He says, okay, John, we're going to do this burn. They got to fire the rockets to try to fix something, and then we're going to shut everything down. He said, we got to shut everything down. In the meantime, we're going to have this cold command module we got to fire up. It's been cold for 3 days. We got to figure out how to do that. We don't know how to do that. This guy says, it's never even been simulated before. He says, we're going to have to figure it out. There's no hope, there's no despair, it's just resolve. We're going to figure this out. We're not going to figure this out, in my opinion, until we are absolutely committed to it. Is it really hard what we got to do? Yes. We got to figure it out, and we got to commit to it. And the way we do that is with the appropriate mindset of an emergency, in my opinion. So, climate change, now what? Identify next steps that you can take and take them. Aim at systemic change. We all have different capacities. We all have different talents. We all have different means. It's not about what your neighbor's doing. It's about what we can do. And here's the opportunity in Inspiration Hall. We've lost a lot already. We're going to lose a lot more. No question. A lot can be saved. A lot can be saved. It won't be saved unless we do what we need to do, these next steps. That's what's motivating me. All the stuff that can still be saved. I do apologize for, sorry. I know that this is big, and I know that this is hard to take in. You got to do what you got to do. Go home, sit with it, figure it out. But we've got to come back to the table and just figure it out. Thank you for your attention. Thanks. Okay. Even.
So we've got about 10 minutes for questions, and then we're going to bring our panelists up and talk about specific actions that are being taken here in our state and other examples. So invite you to stick around. We've got some roving microphones, and anyone who has a question, go ahead and just raise your hand.
And if you need to leave, I'm not offended. Yes.
And our microphones will come around in just a second. We've got Ray on this side. And Abacus over here, so just raise your hand. Go ahead, I see some hands up.
Go ahead. Thank you very much. That was very, yeah. Something I struggle with, on your list where you had, new plans, one thing I felt you were missing, and I'd like your opinion on this, is that even if everyone on the planet, the current population, consumed the most and we switched to renewable energy, I still don't see how we can have a sustainable, viable planet if the human population does not stabilize and then start to decrease.
So the question is about population, and population is absolutely a piece of the equation, but it's not the only piece. There's an impact equation that people use called, it goes impact equals population multiplied by affluence, which is directly tied to consumption, multiplied by technology, which is how efficient we are at affecting the damage. Think of trying to take down a forest with an axe instead of a bulldozer, right? So population is a piece of the equation, but it's not the only piece. And the most critical piece right now, which I think hopefully was clear by the consumption slides, is consumption. It takes, any one of us in this room has about 26 times the energy and material footprint of a Bangladeshi. So in the very immediate concern, it's not about population, it's about consumption. Now, that's not saying that the population isn't a concern as we go down the road, but right now, it's the high consumers that are driving this. And so that's why the discussion focuses I can tell you just about anybody who works in this field, when we talk about the next 10 years, the next 20 years, population isn't really a piece of the puzzle. It's this massive high consumption by the hyper consumers, which is all of us in this room, and it's forced upon us. I mean, we live in this society that just makes us live this way, which that's what we mean when we say we've got to change. So going further down the road to a fully sustainable and just and vibrant human presence on this planet, say a century from now, population is an issue. There's no question. Yeah. I'm just, people who have the microphones. Yes, go ahead.
Okay. So you kind of mentioned it earlier about sort of the inequity of emissions.
Yeah.
Who's actually emitting, who isn't. So my question is kind of two-pronged. The first part is, how do we get the people responsible to be held accountable? And my second part is, how do we make sure that the coalition involved in trying to mitigate these effects includes not just kind of the upper middle classes, but also the ones that will be most affected, like the working class, the working poor?
Okay, so the held accountable part, I don't have a lot to say. There have been deliberate disinformation campaigns and predatory delay that have taken us to where we are. And there's lots of research on that. We know who's done that, and we know what the motivations are, and it's not something I spend a lot of time on. I think the second part of your question is far more important. So, I mean, to a first approximation, my answer to your first question is, to the extent that there are politicians bought and paid for by all kinds of corporate interests, vote them out. Get rid of them. That's, you know, they're standing still. Step around. We just got to vote them out. They're not really what's holding us back. Now, to the other part about making the solutions inclusive of the much more, not just the middle class and the upper classes, but the very vulnerable communities, I would say that this is, in fact, the approach of this legislative umbrella, this policy umbrella called the Green New Deal. The Green New Deal, in my view, is a great approach. Of course, it needs fleshing out. It's not a policy in itself. It's a whole roadmap, and then there are dozens and dozens and dozens of legislative initiatives that have to happen under that. But here's what it is. First of all, it's completely changed the conversation, the political conversation. It's the only proposal we've ever had in this country that is to scale with the problem. Does it need fleshing out and navigating? Of course. But here's the brilliance in my mind of the approach. It puts social justice front and center. Right now, I've said that it's not the people who just refuse to accept these problems that are holding us back. It's two things, and there's lots of data on this. It's those of us who get we have these problems but are not yet behaving like it, number one. So that's why you preach to the choir, you get them to sing. And number two, it's people who just aren't activated on this issue at all. It's not that they don't think climate change is a problem, or they think it's bunk or whatever. It's just that it's not on their radar. They're working 3 jobs, they're trying to get the kids to the hospital, they're trying to pay the medical bills. So the approach of the Green New Deal, and I think the reason I like it is, it doesn't just speak to me morally, but it speaks to me pragmatically. There's precedent for this working, which is the New Deal. You activate people who aren't activated yet. So you might be in a community where most people are just trying to get by and not really thinking too much about this. And they might say to themselves, well, I don't know about this climate change stuff, but that whole set of policy proposals to give me health care, to give me a living wage, to give me education, to give me training, to give my kids daycare and health care, that sounds pretty good to me. I think the intent is that to activate people who aren't yet activated and supporting. And then, of course, it's massive public investment, but you want that why not make that public investment go to where it's needed, to these vulnerable communities, right? Particularly, and there are lots of them, but one example is fossil fuel communities. We got to put them out of business in the fossil fuel business. And we understand that dramatically impacts the livelihoods of quite a number of these communities, so we got to put that in the plan. Let's make sure that they're being specially taken care of, And so I think that to my mind, that as a policy proposal, that speaks to me. And so there's lots of debate to happen there, but I think it's a really good process policy path to follow. Who's got a microphone?
Hey.
We'll go to Forrest and then we'll come back up to you. Yeah.
All right, so 15% recurrent annual reductions as individuals is well and good. I'm on board.
Yep.
But how do we address like the elephants in the room? Things that have become normalized and really can't be reconciled against the emergency mindset that we need. I'm
Like-
talking about things like cruise ships and frequent flyer miles and expecting 2-day Amazon delivery, single-use packaging, all these things that we've become so accustomed to that they're just noise in the background when we talk about the fossil fuel industry.
So the question is, how do we address this systemic stuff? This is what, when you hear the phrase, everything has to change, that's what it means. And all of us in this room, we really want to change this stuff, but we just don't want to change. And so I think historically, this is where public policy makes us do what we don't want to do. World War II is a kind of another nice case example, right? You've got the emergency, you've gotten the public into an emergency mindset, so that's step one. But then what does the public accept? No new cars, rationing of everything you can think of, gasoline, meat, flour, sugar, metal, all of this stuff that then becomes normalized. If it were up to me, if I could put forth one policy proposal, it would be we've got to ration carbon. 44 tons, there's your limit. Use it as you like, right? But at the same, you can't do that without changing the systems either, right? Air travel is a really great example. We just got to have a society that doesn't require us to step on airplanes and doesn't encourage us to step on airplanes as often as we do and doesn't allow us to, at least for a while, to meet the emergency. And then we'll see where it takes us, right? But right now, it's all about the molecules. So public policy has to be there, but in a democratic society, you've got to get the people on board with the emergency, and I would argue that's the storytellers. That's the Bob Dylans and the Steven Spielbergs and the Harriet Beecher Stowe's and the John Steinbecks and all of these people who take these crises that we faced and really made it personal and really helped us as a culture understand what's happening. I think I give a pretty good science lecture, but it's not. People like me have been doing this for 30 years, and maybe even we're getting better at it, but it's not taking us where we need to go. And I don't know the answer, but I would say we've got to have cultural buy-in. It doesn't have to be all of us, but it's got to be a substantial fraction of us committed to this. Yeah, and public policy can then follow. And we've got to just force ourselves to do things we don't want to do. We do that through public policy. Yeah. Who had the other? Yeah.
So my question talks a little bit about the economic portion of this issue. Sorry about my voice, but I'm also a fellow Utahn, and so I had the privilege of going down to Delta, Utah, where, correct me if I'm wrong, I believe it's a coal-fired power plant, and we were able to
yeah.
speak with some of the workers there, and the biggest thing that I heard was, when you make this switch to renewable energy, what happens to me? And I'm out of a job. So my question to you is, what is your response to that? How do you make it sound like something okay for them?
They should be supporting the Green New Deal. Because things like the Green New Deal target exactly that, and more, much more. But they certainly target exactly that person. There's no question. I don't have an answer. But we have people who work on these things, and as a public, we can come up with public policy, I think, that does take care of such people. We get that. It's not their fault. But that doesn't mean that we can just keep spewing this stuff out because it keeps a few hundred Utah coal miners in business. We can't do that. We know that, so we got to take care of them, yeah. Who's got the microphones yet up here?
So I was going to ask you your thoughts on a Green New Deal, but you have answered that very eloquently. So what I am going to ask is, while we can all do our fair share as individuals, you would say that the biggest thing that you can do is joining in a movement or an organization of people that will fight back against the systematic oppression and use of fossil fuels that we have today, and join with the youth strikes on April 22nd on Earth Day, and understand that it is a strike and that there is sacrifice involved with that, but join with us and walk out of school and work on that day.
So I didn't get to my sacrifice versus achievement, but since you pulled it up there, I had a picture of a mountain. And I bet there are a few in this room who climb mountains. And it's really hard and super painful, well, especially if you do something like Everest or K2, right? I mean, it's just miserable. Just miserable. And the people who do it never, ever talk about it that way. It's just the achievement that's just spectacular. So first of all, we could call it sacrifice, but I think the mindset is achievement. You're working towards something big. And okay, we got to push ourselves out of our comfort zone. So yes, I personally believe that there is I have not been able to find any example of societal cultural transformation that has happened in a democratic society without direct action activism in the streets, holding people's feet to the fire. But the movements that are effective are, take the Martin Luther King. I mean, on the one hand, he's got the activists and they're in the streets, but on the other hand, he's on the phone with LBJ saying, we're going to march across the bridge, sign the bill. You know, I mean, there's a political arm moving on the inside, and there's activism arm, and LBJ wants him to make him. He needs him to make him, right? And so we've got movements like that going on across the world right now. Extinction Rebellion is one. They're in-your-face direct action activism, but they also have political arms that are working hard. Here's the solutions. And here in the United States, the Sunrise Movement associated with the Green New Deal is the same way. They've got political arms working on, here's the Green New Deal, here's the stuff, but you've also got the direct action activism that's holding our feet to the fire. On a much more local scale, Montana State University admissions are going up and up and up, or at least level. They got to come down. And students have far more influence on administrators than faculty do. And you got to have actual solutions and actual pathways you want to follow, but you need to make them. And it's absolutely an essential piece of the puzzle, so there's certainly that to do. Whatever you want to do, though, if you want to work in food or energy or whatever, before you start your own movement, take a breath, take a moment, and see what else is going on. I promise you there will be movements you can plug yourself into, and that's much more effective than having 6 movements trying to do, at cross purposes. So, yeah. I'm cognizant of the time, Paul, so.
I think why don't we bring our panelists down right now, if that's all right. Rob will be available for questions as we have the panelists ask questions during the Q&A. He'll be sitting right here. We'll ask Rob to just sit here with his lapel mic off, and then he'll turn it back on as the Q&A starts. So it's my pleasure to welcome our panelists down here to the front, and I'll introduce them as they're coming down. Each of them will spend just a couple of minutes talking about the work that they're doing in their respective, through their respective positions at the state, tribal, city, and campus level. First, this is Patrick Holmes on the left, on my left, on your right. Patrick Holmes is the policy advisor for the natural resources, in the Office of the Governor. Speaking next will be Termaine Awanaki. She is the climate change coordinator for the Blackfeet tribe. Speaking next is Terry Cunningham, who's a commissioner with the city of Bozeman. And then speaking last will be Dan Stevenson, who is the associate vice president for MSU University Services. They'll each speak for about 8 minutes, if that's all right, talking about their professional efforts, any results, and how their work might inspire us. So with that, I'll turn it over to Patrick. And you can either use that microphone if you like, or...
Hello, good evening. My name's Patrick Holmes. As Paul mentioned, I serve as Governor Bullock's Natural Resources Policy Advisor, and I also have the pleasure of chairing Governor Bullock's Climate Solutions Council. As I think many of you know, the governor this past July issued an executive order establishing the Climate Solutions Council and committing the state of Montana to the U.S. Climate Alliance. As part of that, he laid out 3 very broad goals for our work. One is to begin to prepare the state for climate impacts. The second is to develop strategies to reduce our state's greenhouse gas emissions, including achieving carbon neutrality within the electric sector by no later than 2035, and developing a plan to reduce emissions economy-wide at a date that would then be determined by the council. The third area that he tasked us with is helping to address communities in transitions, both as a result of energy transitions and other factors and workers, but also to facilitate opportunities for our state to take advantage of some of the new economic development that can occur in our response to climate change, developing and expanding current and new technologies that can solve some of these challenges. So 3 broad goals for our work. What is interesting, I think, is if you look across our state, Montanans, about 67% of us believe that climate change is happening and are worried about its impacts on future generations. In a state where a lot of policy issues get divided between east and west and urban and rural, interestingly, a majority in every county in the state of Montana feels that way about this issue. They believe it's happening, and they're worried about the impacts for future generations. The problem is when you ask Montanans what we should do about it, we are all over the map right now. We do not have that common set of framework or vision for how we should respond. And so much of the work of our council is to begin to try and build some of that foundation. Let me make a case for why we need climate action planning at the state level briefly. I think you heard whether you are in the 7 out of 10 of us who believe that climate change is happening, or the 3 in 10 or 30% of us who either don't know, don't care, or disagree with the premise, there is a need for our state to move forward and have a thoughtful plan. Part of that is attributed to the physical risks, and Dr. Davies did a fabulous job explaining those at a global scale in terms of what we face. But here in Montana, we have already begun to face many of those risks. We are 3 degrees Fahrenheit on average warmer than we were in 1950. Our fire seasons are by many accounts 78 days longer than they used to be on average. We are experiencing very rapid runoff that causes flooding, that affects our water availability. All of those things are happening today and are projected to get worse. And how we respond to those risks across all levels of government becomes incredibly important to how we adapt to future changes and manage some of the costs of those impacts. But beyond physical risks, we also face risks in other avenues as well. One is a set of fiscal risks. In 2017, we had our worst fire season on record. We had double the incidence of respiratory-related illnesses in the affected counties. We tragically lost the lives of 2 wildland firefighters. But we also prompted a special session of our legislature that required some significant budget cuts that impacted many Montanans in very significant ways. Because we were not prepared for what was an unforeseen, at that time, set of events. Unfortunately, we can anticipate reasonably, looking at the science, that our fire seasons will continue to get more severe. So that's just one example of the ways in which we are impacted fiscally. We're also impacted because many of our revenue sources that service our state government and our agencies are dependent on current fossil fuel extraction. So our ability as a state to continue to provide all of the many services, let alone the types of incentives we may need to respond to this set of challenges that Dr. Davies has outlined, requires some rapid transformation as well. We also face risks that are economic and financial in nature, and our businesses feel that every day. You needn't look any further than BlackRock, a major investor, telling Northwestern Energy to be conscious of the risks of coal-based energy in their portfolio as an indicator of just how large the concerns are regarding the potential for stranded assets. For you and I in our daily lives, we may make important financial decisions about what kind of new car we may buy when our current one runs out of its life, or when we replace a major appliance like a water heater in our home. Those are capital investments that we make that we expect are going to last us for 5, 10, 15 years. When we make those investments, we need to be conscious of these transitions that are around us, because having to remake those investments more than once over that period of time is really what drives the costs of this transition. We can actually control those costs by having a really thoughtful trajectory. And then the last set of risks we have relates to policy as a state. Irrespective of what we do here at the federal level, we can anticipate changes coming. We can see policy changes happening around us in other states. We know that every major nation in the world has committed at some level to these changes. And we need a plan to be responsive to those changes as well. We're a state of 1 million people. And as a state of 1 million people, we are going to be constantly serving those other markets for our economic activity. So how we respond to those challenges to retain a competitive advantage really requires that we be on the forefront. And part of what Governor Bullock is doing with our work is to focus on the many opportunities we have to create economic opportunity in response to these challenges. Things like emerging energy storage technologies, new technologies in our agricultural systems, opportunities to develop renewable fuels that can meet aviation needs. All of these things are needed as part of our transition. They're all going to be in high demand in our region and around the world. And our state can play a leadership role in localizing and developing those economic opportunities here if we get our heads out of the sand and look around the corner. So that's a lot of what we're focusing on with the Climate Solutions Council. It's an exciting time for us. We just put out an initial set of recommendations and key questions. It reflects our early consensus work of the council. It's intended to be the starting point of a conversation and not the end point. And what I would share is that I really invite you all to engage in the work of the council, to download the report. It's available at deq.mt.gov/climate. We'll take any ideas or suggestions you have on how we can improve upon our work and ultimately calibrate it to the ambition that Dr. Davies discussed earlier. You can send us an email at Montana or at climatecouncil@montana.gov, and we'll be taking all of that feedback as we move forward. We have a short timeline to produce recommendations by June. And in order to inform the governor's budget and legislative proposals moving forward. But we've got a great deal of confidence that there's a tremendous amount of work and opportunity to build upon. So I'll close this opening remarks by saying part of the reason that we think we can get a lot done is because of the work that's happening with our tribal nations in the state, with local governments, with others who we can learn from, who are leading the way, and who have developed significant solutions. In wildland fire, there's a saying that no one cares what color the engine is, to use an emergency analogy. You know that when there's a fire, all of government is going to show up and respond to that problem with a sense of urgency to achieve an effective response. We need that same all-of-government approach here in Montana as we tackle these issues, and we're looking forward to building that framework with the work of the Climate Council.
Great. And now I'll introduce Termaine Awanaki, who is going to talk about the Blackfeet tribe and her work as the climate change coordinator.
Okay. Nistuni Taniku Awanaki, Nixist Anasta A Stansky, Genstanasta Pitawasta. Hello and welcome. Thank you for having me. My name is Termaine Edmo, and I'm the Climate Change Coordinator for the Blackfeet Tribe, also known as Awanaki. I want to thank Dr. Rob Davies for saying, worry about your own neighborhood. So we're going to go to my neck of the woods, which is in the Blackfeet Nation. So in 2015, the Blackfeet Tribal Business Council signed resolution putting forth the environmental impacts that have been, start addressing the environmental impacts that have been detrimenting our 1.5 million acre nation, the Blackfeet Nation. Gerald Wagner, the director for the Blackfeet Environmental Office, led this movement with help and guidance from the Confederated and Salish and Kootenai tribes and the Center for Large Landscape Conservation here in Bozeman. With these efforts, we created the Blackfeet Climate Change Adaptation Plan. This plan features 8 sectors: agriculture, fish, land and range, water, wildlife, and human health. Each sector contains climate change impacts, priority levels, and adaptation goals decided throughout the planning process. This plan is a living document, which is continually being updated as priority levels change, as we noticed with the human health sector and our extreme weather. 2018, we were in a state of emergency in my neck of the woods. And with the heavy snowfall and extreme weather, we were losing community members as young as 60, shoveling, trying to make it out of their home for food, for survival, dying of heart attacks, animals starving to death, freezing from these climate change impacts. So extreme weather, such as the heavy snowfall, challenging precipitation patterns, warming temperatures, increasingly prolonged and severe drought, given our high poverty level and rural-based economy, leaves our reservation crippled with our animals in shock and these catastrophic events happening. So, Blackfeet have been caretakers for this soil we walk on for generations and generations. I have had the privilege to grow up to be a traditionalist in my home, practicing our ways. And I've been involved in this planning process from the Climate Change Warriors internship, from being a cultural youth mentor to the climate change coordinator. My experience has led me to the position I am now, to keep my community informed and updated. So the Blackfeet people were destined to be the most resilient people on the continent. Our power is within each one of us. Our songs, our dances, our language all make us unique. From the Natuyita beings, from the above beings, to the Sikamita beings, to us land beings, to the Suyita beings, the underwater beings. Each have guided us and helped us through our different stages of life. We can adapt, and we can begin to change the landscape when we start to retell our story, when we share this traditional ecological knowledge. Amskapi Bigani, or the Blackfeet people, have been doing this for thousands and thousands of years. We adapt from our shelter, to our clothing, to our food. We're naturally changing and adapting. The weather also changes us, and plants, for example, as our winters are not as harsh. Some of them, like this winter, has been extremely mild compared to years before. And we're worried with the plant disruption and growth that our ways are being lost. Our medicinal properties from our plants are being forgotten. Our gatherers are losing their way of life, all from climate change impacts. You can see some of our diseases are flourishing. So this adaptation is the first step in holistic healing to large landscape recovery. The Blackfeet Nation is the first tribe to use traditional ecological knowledge to fight climate change. With this adaptation in place, we started to implement our strategies from the water sector. The Gistigi project, or the Beaver project, was a direct goal targeting each one of our strategies from the water sector. This included to reduce the frequency of higher intensity floods, to assess floodplains to mitigate future property damage, and to ensure downstream users have access to sufficient waterways and water qualities. The Gistigi project has increased natural water storage, restored streams, wetlands, culture, and our history. This project is a restoration technique where we build small dam-like features using natural materials such as rocks, sod, willows, and pine for the posts. So we built a team of eco-engineers and future climatologists not only combating climate change, but revitalizing our culture and our history. As First Nations people, we're reconnecting floodplains, increasing water storage, and conserving habitat, all while preparing us for future generations to come. And any more questions, or if you want to get involved, want to know more, you can check us out at blackfeetclimatechange.com or / the Gistagee Project. Everything is on our webpage. Thank you.
Thank you, Termaine. Next, we will hear from Terry Cunningham, Commissioner with the City of Bozeman.
I don't share my colleague's talent of being able to present a slideshow that is behind me. So Paul, if you could help me pull up the City of Bozeman. Oh, okay. Well, there you go. There we go. So I'm Terry Cunningham. I'm one of the 5 Bozeman City Commissioners, and I bring greetings from Mayor Mell, from Deputy Mayor Andrews, from Commissioner Pomeroy, and from Commissioner Wallner. So we heard Dr. Davies speak in the Mountain Towns Conference, and we wanted to bring him along with MSU Sustainability here so that you could hear what we heard, and as a result, feel what we feel. So we argue that there's not only just a climate crisis going on, but there's a crisis in leadership. How many people here believe that the federal government is coming to the rescue in this issue? I would ask you to raise your same hand for the legislature or the PSC, but I don't want to get into politics. I just want to assure you that the rescue squad is not on the way. Or looking at it differently, we are the rescue squad. We are the rescue squad. So there are at least 3 Montana municipalities that have set aggressive climate change goals, and I think we can add Whitefish to that as well. It's Bozeman, Helena, and Missoula, pursuing 100% net renewable energy and other aggressive goals. And MSU is also leading the way. Change is going to have to come from the bottom up because it's not going to come from the top down. A little overview of what we have done in terms of being in the climate space as a city. In 2006, Mayor Kraus signed us up to the U.S. Mayor's Climate Protection Agreement. In 2008, we put out our first municipal climate action plan. In 2011, we put forward the Community Action Plan. In 2017, then Mayor Carson Taylor signed us up for the Mayor's Compact of Mayors to uphold the tenets of the Paris Climate Agreement. In 2019, our Sustainability Director, Natalie Meyer, and Strategic Services Director, John Henderson, did a climate vulnerability assessment and resiliency strategy, and we have just started our update of our climate plan. And I want to run through this a little bit. So we have had some successes. Just from our own municipal energy usage, we've decreased that, and we've saved roughly the annual emissions of 538 Subaru Foresters. Incidentally, there are probably 538 Subaru Foresters in the parking garage right now. Also through our energy program with businesses and through our community solar, we have seen considerable greenhouse gas reductions from that as well. The Montana Climate Assessment has told us, in terms of adaptations, what we're going to have to adapt to. More heat, more floods, more drought, thinner snowpack, more wildfire, more severe storms when we have them. So what we did the Climate Vulnerability Assessment and Resiliency Strategy in concert with MSU, in concert with Gallatin County Emergency Management. And some of the highlights of those, although the recommendations were quite extensive, in the area of infrastructure, we have to be ready for emergencies with communication, with backup power, and in the area of increased capacity for our air filtration systems for places like the senior center for periods of prolonged fire, exposure to wildfire smoke. In terms of policy, we have to, and we are, mandating conservation at certain times when it comes to water, and updating the engineering practices for our stormwater management so that we can actually be able to deal with the coming floods. But what I want to talk to you about most importantly is we are currently updating our climate plan And as you can see from the word cloud, there are words that our climate team is focusing on, like bold and actionable and ambitious, but also equitable and collaborative and inclusive. And it's important that we have all of that in our climate plan. We've assembled a climate team. We started it in July, and we are working our way to a plan that will be presented to the public and eventually presented to the commission. So who is the rescue squad in this case? We've assembled over 35 people with an emphasis on youth, with an emphasis on expert information, and we want all the people at the table can actually help us develop this plan. And we've developed some goals. These goals have been presented by the Climate Action Team. They've been ratified by the Commission. Here's where we want to go. We want to reduce our greenhouse gas emissions by 26% by 2025. We want to be at 100% net clean electricity by 2030, and we're going to need the help of our utility in order to do that. And we want to be a carbon neutral community by 2050. And you can't just put those goals out there and hope that it happens. You got to make it happen. You got to figure out, let's show our work. How are we going to make this happen? And so we're concentrating in these 6 areas. And I'll break down some ideas of what we're working on in each of these areas. So our climate team has developed subcommittees, and they're working on how do we get to our goals in all of these areas. Undergirding all of this is that it has to be equitable, a focus on health and human well-being, and it brings to bear all of our city assets. So what are some of the ideas we're looking at? In the area of green space is to encourage and increase the local food production, to stop exporting our wetlands out of our local watershed, and develop a biochar urban forest program. These are some of the ideas that are being talked about in this area. In terms of community development, co-housing, focusing on a sharing economy, making sure that HOAs, that their covenants emphasize resilience and conservation, looking at EVs and electrification as a community, and working with our partners in Gallatin County and in Belgrade and other cities, that when we grow, we try to focus in an urban environment rather than sprawling all over the valleys and into the foothills of the Bridgers. Buildings account for over 50% of all of our greenhouse gas emissions as a community, so making a difference in this area is really important. We cannot require new buildings to exceed the Montana Building Code, but we can incentivize them to do so. We can work with all of the people associated with home building and sales to emphasize the value of an efficient home. We can support weatherization programs like PACE and require that energy use for each home is disclosed as a condition of sale. We have heavy lifting to do in energy and utilities, working to identify where our city facilities can be used for solar and other properties, partnering with our utility so that we can, on a utility scale project of renewables, buy 100% net clean renewable energy from our utility. Working with consumers so that they know what the cost of using different electrical assets at different times are to move them to off-peak demand, and to think about a carbon fee for what we use as a city. Again, all of these ideas are being discussed in this subcommittee. We know about recycling, but we're trying to emphasize reuse and reducing our waste. We want to move into a citywide food composting program and work with the people in the building industry so we separate out, not everything has to go to the landfill, there's plenty of opportunities for reuse. Transportation, over 35% of our emissions happen in this area, so we have to make a difference here. Changing the hierarchy of what we're developing transportation for should be people, bicycles, transit, then single occupancy cars. We need to work with Streamline to make sure that our transit system is convenient and well-funded. We have to work on parking, and we have to plan to be a community that has electrical vehicles in our transit system and in our passenger vehicles. How do you get involved? Demand action. Participate. Most importantly, vote. Help is not coming. unless you make it come. Bobby Kennedy once famously said, if not us, who? If not now, when? Brothers and sisters, it has to be us, and it has to be now. Thank you.
Thanks, Terry. Our last panelist is Dan Stevenson, Associate Vice President for MSU University Services.
All right, thank you, Paul. Great presentation, Terry, and we very much support and work with our partners at the city with the climate action planning that's going to happen here very soon. So they saved the engineer for last. Congratulations. There'll be a little bit of thermodynamics, but not a lot. Paul, I'm not. I'm going.
Give me 1 second.
All right. All right, there we go. So Dan Stevenson here with MSU, and I'm going to talk to you about something very specific today, and that is this one slide, I guess. Okay, there we go, and that's our energy planning at MSU. And I want to harken back to our mission as an education and research institution, and within that mission, stewardship of our natural and financial resources is at the very top of what I'm responsible for in the area of the physical operation of our campus. So our energy strategy really focuses on developing a plan that focuses on that area of sustainability and stewardship. And then what we're going to talk about now is the implementation of a practical and progressive low-carbon strategy that provides us a roadmap to carbon neutrality. So very quickly, actually, Paul, could you go to one more slide, and then we'll come back to that slide. Thank you very much. I'm going to touch on greenhouse gas emissions over this period of time, because this is a period of time that we have the best data for right now. Between fiscal year 2008 and 2016, we actually saw a total reduction of somewhere around 17% in our greenhouse gas emissions. We measure those with very specific sideboards on that, so I won't go into detail about that. But the takeaway from that slide is that we have reduced our greenhouse gas emissions at the same time that we had about a 30% enrollment increase and about a 10% increase in the amount of campus square footage that we had. Which is okay. We're headed the right direction, but we have a lot of work to do. This slide kind of drills down on that data a little bit to talk about energy specifically. The blue base of the bar graphs is our electric energy intensity on campus. The yellow is the natural gas or fossil intensity. When I say intensity, we measure that in energy utilization index, EUI. How much energy per square foot does our campus use? You can think of that as a mile per gallon rating for our campus and specifically for our buildings as well. You can go ahead and move on, Paul. So within the energy use of campus, we have electric and we have natural gas as our two focus areas when it comes to climate action planning. The component of that equation, the natural gas, is our direct fossil combusted fuel here on campus. As a general rule of thumb, once you burn something, it's very hard to unburn it unless you're a tree. So our strategy really focuses on what can we do to mitigate the direct combustion of fossil fuels on campus. So in order to do that, we need to kind of step back in time, step back in history, and understand how do systems work in buildings such as this? How do they historically work? Well, this is the thermodynamics part. We're not going to talk about any thermodynamics really, but we make cooling and we make heating. And the part of our history that is uncomfortable and has been so damaging and has gotten us largely into the condition that Rob talked about earlier, is that while we're making heat in many of our buildings, well, this is the way we've done it forever. We will heat a building, and then in that very same building, we will expend energy. We will make cooling to throw heat away. So we make heat, we move it around, it gets to a place where it's undesirable, and we throw it away. So now that we understand that for decades, really for centuries, that's how we have treated energy in our standard conventional design, we can move on to our energy strategy. So I think of energy strategy at MSU really is a R-cubed approach. The very first thing that we do is we reduce energy in our system by improving system efficiency and integrating design, that being architecture and engineering, to result in a better, higher performing end result, such as the building that you're setting in right now, for example. So that reduction is something that happens during the design process or the retrofit process of a building. And then reclamation, that is where instead of having an energy stream happen and then eventually throwing it away, we focus on how do we capture all of the energy that we have brought into our building and keep that energy for as long as we possibly can. And I'm going to talk to you about some innovative ways that we're doing that here at MSU right now. But finally, we look at integration of renewable sources into our buildings. And when we have more time someday, I'd love to give a presentation on how we've integrated these into this building. These energy systems that can enable a low or no carbon operation include district heat pump systems. A heat pump is kind of a fancy term for a refrigerator that can move heat from one place to another and be reversed to, depending on whether you want the heat in or out of the space. We use geothermal wells. We've deployed geothermal bores around campus. Here at this building, at the American Indian Hall, we are preparing to do so in Romney Oval. And we also have, I didn't list it here, but down by Jabs Hall, we have a geothermal field there. So we have been distributing geothermal assets on campus that then we will network the buildings together over time as we have strategic availability to do so. Then, of course, we're in the early phases of integrating photovoltaics not only into our buildings, but we hope to do some mass ground mount systems at some point too. We're still in the planning phase there. Finally, energy storage is something that we're just on the brink of understanding how we use energy storage on campus to allow us to maximize, to leverage renewable energy production, be that production on campus or be that somewhere else on the utility grid. So those really are that's the backbone of the energy strategy that we have here at MSU. And now we can talk a little bit more about the effectiveness to what we've done. The very first energy district where we've tried to stitch buildings together to share energy, to reclaim that energy, happened in the Leon Johnson area. And this really crazy graph, and I don't think, well, maybe I do have a little light, is really showing we've integrated Jabs Hall, Leon Johnson Hall, Teets Hall, Wilson Hall, and this shows what that total energy district looks like altogether. And again, this is the energy use index or the mile per gallon type rating that we use for each building. And the important thing about these trends is you can see that each of these buildings started from some very high point and has reduced. And the net result of being able to share energy between buildings and then leverage a geothermal asset. When I say a geothermal asset, we're drilling a hole in the ground about 7 inches around, and it goes down in the ground about 500 feet. The latest geothermal asset we're doing will go 700 feet in the ground. And then we run a fluid, water essentially, down into the ground and back up. We don't extract water from the ground. We exchange heat to or from the ground up to the heat pump systems. And what that does is allows us to use the ground as a battery and allows us to use it as our very first form of thermal energy going into this set of buildings. The net result overall has been about a 30% reduction in energy going into this set of buildings. In the most intense, or I should say the most high magnitude energy building, Leon Johnson Hall itself, it actually reduced the building by nearly half. The important part of this story is that the half of the energy that was reduced from Leon Johnson and the energy that was reduced from all of these buildings is almost completely the direct fossil combustion of natural gas on campus. That's an incredibly important part of the strategy, and I'm going to come back to it a little bit later. I started with this slide because when it comes to figuring out how to wring the carbon out of buildings, new buildings are frankly pretty easy. We have the technology. You just need the willpower, you need the design team to get there. Existing buildings are incredibly challenging. So what we're showing here is we can get there with a very diverse set of existing buildings, and we can change how energy happens in existing buildings. And of course, most of our buildings are existing right now. Okay, so that was the hard part, talking about the existing construction. Now, the same EUI comparison for some new buildings that we've done here on campus. As many of you know, we've had a lot of experience with new construction recently, and we're getting better at it. I've been doing this for about 28 years now, and I still haven't seen a perfect project, but we've got a set of buildings here that show Cooley, our chemistry biochem building, Barnard Hall, which is our engineering building, and other what I will call legacy conventional buildings on campus. On either side of that set of buildings, we have Jabs Hall and Norm Asbjornson Hall, the building that you're in right now. So what we're showing here is that the mile per gallon rating of the two of the newest buildings that we have on campus is multitudes less energy intense than our existing buildings. So we're proving we can get there with the approach that we've adopted. And what we're coming up here with is a very interesting story that I think Paul wanted us to talk a little bit about how what we're doing here on campus can affect you and the society and people beyond MSU. Well, this is an incredibly good story that we're working on right now. We're on about chapter 3, I'd say, of a long story that, Paul, if you'll go one more, really is going to culminate in, I guess, what I'd call maybe one of the series of the Harry Potter books. And Atticus over here, earlier today, I sat in the back of the master's class, and Atticus had said that his goal in education is to come up with low, actually negative carbon building materials. So I thought in my mind, well, that's another book. That's another book in the series. So at the end of the day, what this really means is, as Rob said earlier, we all have a role to play in the issue ahead of us. And my role and MSU's role as it relates to the physical operation of campus is to get to this point here. As we prove that these individual buildings can operate at incredibly high levels of energy efficiency and we can integrate renewables, the next step is if you think of this green ring as an energy interstate, just slowly moving around campus, and each building, be it the red ones or the yellow ones, and they're different colors because of different phases of their integration to this system, can either pull heat out of that energy interstate or put heat into it, on-ramp or off-ramp. And the blue assets, that is the Norm Asbjornson geothermal bore field, and Romney Hall, we're in the process of rebuilding the infrastructure, rebuilding the landscape, and in the process we will put a total of 21 miles of piping of geothermal heat exchanger in Romney Oval. It'll become a tremendous asset in the middle of campus that we can use to heat and cool our buildings, thus retiring that thermal energy side of the equation. When we retire the thermal energy, that's when our partners at Northwestern Energy and other utility partners become incredibly important. Because what are we doing now? We've electrified our system. Where we get our electricity from is incredibly important. We can get some of it from campus. We can do some of that, but at the end of the day, we're gonna depend heavily on our utility partner to help us green the grid and get electricity in the most sustainable way. Finally, why this is important to us and beyond is because at the end of the day, buildings, be they residential or commercial, are a huge component of the entire energy pie within the civilized world. So this is the part that I'm going to work on, and I think tonight was very good to talk about or think about what we're all going to work on. Thank you.
Well, we appreciate your patience. We do have time for some questions for any of our panelists or for Rob, who's still here. We do have some roving mics. I'd asked Atticus and Ray to, if you just want to put your hand up and see if you have any last questions, if you still have some energy. Any questions at all? Comments? We've got one here and one in the back there.
A question for Dan. Would you guys be open to doing tours during Earth Week when we're trying to show off and showcase some of the stuff that we're doing in town?
I can't figure out how to turn on the microphone, so.
All right, yeah, there we go. Thank you very much. Absolutely. And at the end of tonight, if you'd like, I'll give you a business card. I would be more than happy to provide any level of tour you'd like to have. You bet.
We have a question in the back here.
Sure. I was kind of curious. I feel like as a state, we're kind of stuck with Northwestern Energy, whether we like it or not. And I was just curious to see if, as agents of the state or local communities and stuff like that, correct me if I'm wrong, but I don't think Northwestern's trying to push almost any new renewable energy expansion projects in the future. And I was just kind of curious to see if any of you guys had any potential way that either the community or yourselves could maybe put pressure on a agency like Northwestern to kind of get more renewable energy for the state and for everyone to be able to purchase into.
It's a great question. The counsel I would offer is, there are a number of places where you're able to influence outcomes of Northwestern Energy's investment decisions and procurement plans. And chief among them is the Public Service Commission. That is where a lot of the policy is going to be set through relatively arcane processes of analyzing how costs are to be shared or passed along either to ratepayers or to investors. And that is the policy mechanism by which we as a state are regulating what is a monopoly interest in the state. So being engaged in the commission is really important, and I think a lot of people don't realize that that's the first venue where you need to show up. The second venue is the legislature, and the legislature has the power to set in stone certain obligations for the state's investor-owned utilities and for our rural electric cooperatives. It's another opportunity to be engaged and have an impact. And then certainly the executive branch of state government can have influence as well. What I would say is an important outlet is the Consumer Council in advocating for your rights as a consumer to have good information, to make sure that decisions are transparent and that you have an opportunity to evaluate what risks and costs are potentially being borne by you in the future by the decisions that are being made. So I would encourage you to avail yourselves of all of those avenues, and it's really pushing on all of those fronts that's going to be important to effectuating a change.
Other comments from our panelists?
So
Northwestern Energy, right now, their portfolio is about 61 to 62% renewable energy, which is better than most. Unfortunately, in my opinion, a move towards additional coal puts it more like 57, 58%. In my view, that's not moving in the right direction. So one of the things that we are exploring as a city, in concert with some of those other cities that have developed renewable energy programs, is how we can, as individual cities, work with Northwestern. Well, we would represent, for instance, those three cities, Missoula, Bozeman, and Helena, roughly 60% of Northwestern Energy's customers, to engage in discussions with them to bring about 100% renewable energy. The delta, the gap between 61 and 62 and 100 is where we want to be, and we need to start eliminating that gap, not just for Bozeman City residents and Missoula City residents, and do it in a way that is equitable throughout, because if we have a procurement plan that gives us 100% and it comes at the expense of another community, that's not something we want to be involved in. So we are in those discussions right now, is what I can tell you.
Another question here.
So there are 7 carbon pricing proposals in the U.S. House right now. I know some of you know about this. How do you think a federal carbon price would affect Northwestern Energy?
I really don't have a response to that. Yeah, an easy question, right? For a long time, Northwestern was disclosing and modeling the impacts of a price on carbon in a lot of its decisions. And that modeling is still done on a routine basis as they think about what the future may bring for them. So I think it's a question that's really appropriately posed to them. I will say that a price on carbon would have a significant impact if they were to proceed with acquiring what is new generation, additional generation that has a high carbon impact. And that would ultimately implicate other decisions they're making. So what I would say is it's worth sort of highlighting that that modeling of what that price of carbon might look like is information that's probably readily available and information that we ought to be exploring and sharing as we think about decisions moving forward.
Another question in the back.
This question is for Ms. Edmo. Am I saying that correctly? Edmo. When you're engaging with community members on the Blackfeet Nation, are you finding that most of the engagement is coming from younger generations?
Yes, for sure. And that's who I'm targeting most, is the youth, because I believe they're the ones to make the change and the action happen.
Do you see that also as a path for improved mental health and crisis management?
Yes, I find myself as a grievance counselor for, and not only agriculturalists, but, just from our extreme weather. We have a lot of impacts that hit our community hard. And so dealing with that it does have a big toll on our mental health.
Thank you.
Questions? Going once? We've got one here, and then down front.
I'd like to pick up where you just left off about mental health and think about the presentation we just saw, which can bring perhaps a feeling of loss about what we thought the future might be for ourselves or for our children, grandchildren. And maybe this is a question for Mr. Davies, but I'm particularly interested in how the process of grieving and specifically addressing that loss at a personal level or in community is an essential part of coping with the projected losses and sacrifices we need to make. And then he said, don't linger in despair and don't necessarily count on hope. But I think when we lose a loved one, whether through natural processes of dying or suicide loss or other mental illness loss, that is an experience of grief that needs to be grieved. And I'm just curious how, Mr. Davies, you or others that you're seeing are taking the mental health toll and what steps people are doing maybe that includes climbing a mountain, but sometimes people who are very depressed aren't able to do that. And I see a lot of depression among young people, people thinking they won't have children, et cetera. It's a difficult future that we're facing. I'm just curious if anyone would like to address the mental health piece. Thanks.
I'll start just by saying I certainly didn't mean to be callous about this and just say climb a mountain and don't be depressed. It's a great question, and I'm on Twitter. Most of the people I follow are doing similar sorts of work that I do, and this is a huge discussion. I think the person that I've seen that speaks most eloquently and effectively about this is Joanna Macy, who is just a national treasure, so if you Google Joanna Macy, she has a number of talks where she speaks about grief on these issues, and she's written about it, and she's not the only one, quite eloquently. It's absolutely essential, as you said, and I can tell you I've done my share of it, and I will do more. The best that I can offer is seek out help. There is help available. There are support groups. There's just help in knowing having a community. But then, of course, there's professional counseling and that we need to not be afraid to use, and I have used. And I know many of the people who do the kind of work that I do have used. So it's a great topic. It's a great question. It's a big topic in the world that I work in, and I certainly didn't also mean to give it short shrift by saying just climb a mountain. Self-care is absolutely critical. We're no good to anyone if we're just not able to move forward, and the grieving process is clearly hugely important. Yeah.
Our panelists care to answer this, address this?
So I would just briefly add, one of the great assets that our state has is the Montana Climate Assessment and the work that Dr. Bruce Maxwell, Dr. Kathy Whitlock, Tom Armstrong, Scott Bischke, several others here in the audience who are also on our Climate Solutions Council helped put together. And they continue to do work exploring the ways in which climate change will impact human health in Montana, including mental health, and are working with practitioners to figure out the types of strategies that we need to think about in responding. So there's an active discussion happening at the state level about what we need to be doing, and I agree with the comments that Dr. Davies made. It's an important set of issues, and at least one of the many things we need to do is to be able to apply ourselves to that next step in solving problems.
If I could add just one thing, having heard Dr. Davies' presentation and knowing what was coming, and it is a shock to the heart. It is something that you have to react to. One of the things that is very important is for young people to have hope, and not just fairy tale hope, but real hope. And making sure that we as a community, we as MSU, we as we're talking to members of our tribal community, have hope and give reason for hope. Not just say have hope. Say have hope and here's why. Here's how you can connect and here's how you can make a difference. Because hope without a goal is not realistic. So I think part of that grieving process is turning grief into energy, turning grief into action, and being able to envision yourself in a world that is different than the world that you encounter. So it's incumbent upon all of us to work towards a community and a country that provides real hope to our children.
So at a young age, we've learned to adapt to grief. As a Native American, we face the most loss in our communities. We lose brothers, mothers, sisters, uncles, aunts, everyone around us closest to us. I think it's crazy that people only have 2 cousins sometimes, and I'm just like, what? So we adapt to our surroundings. We really, as Native American, again, we find our grief within our humor. So we find humor, we find a way to cope with them, we find those mechanisms. And what I'm trying to bring back and implement is our traditional ecological knowledge to find that cultural identity. So these students who are just growing up, we can't just tell them, go find hope. go climb a mountain. Yeah, we can tell anybody that. But how do you do that? What are the steps to taking that mountain? What are your vows to your higher power? What do you envision yourself when you get on top of that mountain? What have you accomplished within yourself? So we teach these things through our traditional knowledge, and spreading that is, again, going back to what Dr. Davies said, is in your own neighborhood. It's adapting to where you are at this moment in time.
One final thought. I find that anxiety really breeds a lot of feelings of fear and result in depression if you don't address it soon enough. And the most impactful thing that I think will come from the story that we're beginning to develop at MSU is frank, that the energy and the carbon reduction, the path to neutrality is important, but the most important thing is showing the next generation or the generations to come of thinkers and doers that it can happen, and giving them the beginning of what they will take and make multifold better than what we're doing today. Someday they'll look back and say, oh, I remember that old stuff at MSU, but it will be the beginning and will allow them to have hope that they can move forward and truly change the world.
Why don't we conclude? We've got a question here, and then, did we have a question here as well? Okay, so just these last two questions then?
Okay, my question is for Dr. Davies, and I'm going to hand you the mic here in a minute, but go away from the social, but back to a kind of a biochemical question. One of the buzzwords I've heard for years and years and years, carbon sequestration, vegetative management. Some of your slides showed the deforestation in the tropical rainforest and, annual invasives versus perennial bunch grasses, things like that. In your perspective, is vegetation management really pivotal in terms of carbon sequestration, or is it kind of a myth or a unicorn? It sounds good, but may never make a difference. I'm just curious.
Right, so it's a great question. And the short answer is, I'm not sure if pivotal is the right word, but I've never seen, so I showed you Kevin Anderson, the carbon modeler, who said the 4C world is not, et cetera, et cetera. He does a lot of this kind of modeling, and I've never seen a roadmap that does not include this piece. And there's kind of a common phrase, there's no silver bullet, there's only silver buckshot. So there's lots of pieces to it, and I've never seen one that doesn't include this piece of vegetative. And it can play different roles. It's highly regional. It plays very different roles in different regions and has a lot of different capacity in different regions. But everybody talks about soil sequestration, vegetative sequestration, reforestation, afforestation. It's always in the discussion.
Great. And our last question of the evening.
My question is for Ms. Edmo. And so working in a tribal community is very unique, very different than working in Bozeman or overseeing all of Montana. I was wondering if you can share some of the strengths that you get from your community and your people, and how those strengths have benefited your climate action.
So our strengths come from within our stories, and that is what hits home the most, because we know these people, and seeing their growth in the community is what makes our community sustainable and livable for future generations. So actually seeing these students go off and into bigger institutions and coming back and applying that knowledge to better and sustain our community is what makes us thrive. It's those livable moments, I guess. It's I don't know how to explain it, but it's the stories for sure that hit home the most, and it's what makes my job knowing I made a difference, knowing I made that little step in my neighborhood.
All right, well, on that note, a heartfelt thank you on behalf of all of our sponsors. How about another round of applause for our panelists and for Dr. Davies? Thank you all for joining us this evening.